Okay, so let's take a look at this tricky combinations question from AS level statistics. Find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters, if the 2 C's must be in different groups. So this is a combinations question with repeating terms. So the 2 C's in crocodile repeat, and so do the 2 O's in crocodile. So we have 2 items that repeat twice. This means we have to consider each duplicate item manually, because unlike permutations, the order does not matter in combinations, which means if we have repeating elements, then we can't just divide by the number of permutations of the repeating elements. So for this, we need to write out all the different possible arrangements of O, because the C's must be in different groups. So we have a C, 2 spaces, another C, 2 free spaces, and then 3 free spaces. So we have 9 spaces in total, of which 2 are occupied. But these are separate groups, which means if 2 groups are equal, or if 2 groups are the same, they count as the same combination. They are not separate combinations. So we have to look out for symmetry, because the C over here is the same as the C over here, which means these groups are symmetric. So we will likely see 2 repetitions in some combinations. Okay, so let's find the different ways we can arrange the O's. So in one case, we can have an O in this slot, nothing here, an O in this slot, and nothing here, and then 3 blank spaces. Now, we can use combinations over here. We can say that there's 1 slot, and since there's 1 slot, R will equal to 1, and we have 5 remaining letters, because 9 minus 4 equals 5. There are 4 letters being used up in this arrangement, and only 5 unique ones left. So 5C1 times 5 minus 1 is 4, 4C1 times 3C3 will be the formula for this arrangement, because there's 1 space over here, 1 space over here, and 3 spaces over here. And each time we use a letter, we can't use it again. Now it's important to note that these 2 groups are now similar. They are symmetric. If we put a letter over here, let's say we chuck R over here, and then we have a D over here. This is the same as having a D over here and an R over here. And this will happen twice for every unique letter, so we have to divide this by 2. Always watch out for symmetry. Okay, so there's another case where this applies. So we have 2 blanks over here, 2 blanks over here, and we chuck both O's in their own group. Again, this is symmetrical because the 2 C's are equal, and we can chuck 2 different letters in each one, and then we can repeat it twice. So same goes. 5C2 times 3C2, because 5 minus 2 is 3, times 1C1, because there's only 1 space left over here. Okay, so the next one is going to be an O over here, nothing over here, 2 empty spaces, and then a single O over here. Formula for this will be 5C1 due to 1 space, 5 minus 1 is 4, 4C2, because 2 different spaces, and then we have 2C2 because we have 2 free spaces and 2 letters left. And then there's one last arrangement where both O's go in the same group with one of the C's, and everything else will be left blank. This is simply going to be 5C0. There's no slots left, so 5C0 times 5 minus 0 is going to be 5. We still have 5 letters left, 5C2. And then we have 3C3. Now remember, we have to divide this by 2 because it's symmetric. And this, if we add up all of these combinations, we will get the right answer. So let's do that. 5 times 4, because 5C1 times 4C1 times 3C3 divided by 2 will be 5 times 4 times 1 divided by 2. 20 over 2 will be 10. 10 times 3 times 1 divided by 2 will be 15. 5 times 6 times 1 will equal to 13, not 13, will equal to 30. Okay, and then 5C0 will be 1, so 1 times 10 times 1 will equal to 10. And if we add these all up, we should get 65 as the correct answer. Now the mark scheme will say 80 if you have the old mark scheme, but that mark scheme is wrong because they forget to divide one of the combinations by 2. They forget that one of them is symmetric. So if you found this video helpful, please like and subscribe.